This session we will see how we can read and write data to the JSON. So JSON stands for JavaScript Object Notation. So it is one of the most commonly used or standard formats, especially for the transmission of data through the web. So it's normal to use this data format, especially when we are doing web scraping to scrape the required data from the web page. JSON is a very commonly used format. And why JSON is so commonly used is it's a lightweight format as compared to XML. So it's very good for storing and transporting data. And hence JSON is oftenly used when data is sent from a server to a web page. Also, JSON is self-describing. It's very easy to understand the JSON format. So let's see a simple example of a JSON. Suppose I want to create a JSON file for an employee with 3 records. Let's say the employee, we have an array of 3 employee records, which we call it as objects. So this is how you create a JSON file. So you put a JSON file within the curly brackets or flower brackets, and this is employees. Basically, if you actually see, this is very similar to dictionary in Python. JSON is very similar to dictionary. This will be the keys, and these are the values, which again we are enclosing between flower brackets. And these 3 array objects we are enclosing within the square brackets. So this example shows that employees is actually an array, and it contains these 3 objects with first name and last name for each person. So JSON is syntactically, if you see, it's also identified to very identical to the code for creating JavaScript objects, and because of its similarity, a JavaScript program can easily convert JSON data into a native JavaScript objects. So, and also the JSON, when we saw the syntax, it's very similar to that of the Python dictionary, and it is if you compare JSON to our XML, it is quite easier to write JSON file and quite shorter as compared to an XML. And for that reason, we can quickly pass through the browsers using JSON, since it follows the JavaScript syntax. And hence JSON is ideal for transporting the data between client and a server. So let's see the difference between JSON and XML. JSON stands for JavaScript Object Notation. XML stands for Extensible Markup Language. Now both these formats are very commonly used for structuring and for exchanging data to and between a client and a server, or to extract data from a server, or for mainly for web scraping. Both these formats are very commonly used. The difference is JSON uses a key value structure, just like we saw now. This is the key and these are the values, very similar to the dictionaries in Python. But XML uses the tag-based structure. This is one of the main difference. JSON uses a key structure, XML uses the tag-based structure to make it platform independent. Now JSON, as we saw, it has a key value pairs. It's very easy to read and write for us. Whereas if you see XML, it is highly extensible, allowing the developers to define custom tags and structures which is suited to specific needs. So it's highly extensible as compared to JSON. JSON is called as lightweight as compared to XML. That's because it's very easier to write a JSON file as compared to an XML, and quite shorter version, and therefore it's faster. It provides faster parsing of the data and also has smaller data payloads. XML as such has a very rigorous validation and data integrity checks. So it's these are the advantages of XML. Very rigorous validation it has, and very good data integrity. So this is how you can write. We have taken a similar data, and the same thing how we can write it in JSON and XML is shown here. We are just trying to create 4 records of people with the first name and last name. So you can see that when we are writing a JSON file, you have to start with the curly brackets. This is the end of the curly brackets. This is the key, so we are giving the key as tutorials, and open the square brackets, and within square brackets I have 4 objects which are again enclosed within curly brackets. Now the same representation using XML, you can see the difference. This will have tags. So you start with the tutorials as a tag, and again with the ending tag. Again you have one more tag for each and every row. You have a starting tag and a ending tag. You have a head tag and a end tag. So as you can see that JSON is very easier to write. It's very highly efficient and it's known for its simplicity, and hence it's very commonly used for building the web applications or APIs. Whereas XML is robust and it is quite extensible, and it is very good when we are working with legacy systems or document based workflows. So let's now see on the Jupyter notebook, keeping in relevant to our concept, to our tutorials, we have been talking about input-output APIs, where we are trying to read data frames into a file as well as writing from the file and creating a new data frame. So being on the same lines today as well, we will do the same thing. We will try to create a JSON file, and from the JSON we will first convert a data frame to a JSON file, and we will also do the reverse. So let's now open the Jupyter notebook and import the Pandas, NumPy and JSON. You have to import the JSON module as well. Now for the first part, what we are going to do is, now we are going to create a JSON file from our Python script. So let's first create a data frame in our Python script, and from this data frame is now going to be created into a JSON file automatically. So I have already created a data frame here, pd.dataframe. I have created a 4x4 data frame, and these are the indexes and columns. So just execute and see, shift enter, shift enter, shift enter. So if you see what's there in the frame, so you need to wait. Okay, so this is the data frame which we have now created. Now what we are going to do is, I'm going to create a, now we have defined the data frame. So from this data frame, I'm going to call the function called as to_JSON function, and to this function I'm going to pass the argument as the name of the file of the JSON that we are going to create. So let's call the create a JSON file. So how do you do it is, you have to use the data frame. Name of the data frame in our case is frame. We are calling the name of our data frame is frame. So for this data frame, I'm going to call this function frame.to_JSON, and the arguments to this would be the name of the JSON file that I'm going to create. Okay, so frame.json will be the file that would be created in our directory of Jupyter notebook. And what does this function do is, it will take the data frame, the value of this data frame, create a JSON file which would be automatically converted into a JSON file. Just execute this. So after executing this, if you go to your directory, you should be able to find a file with this name, frame.json. So search for the file frame.json. Yes, it's here. So this is the JSON file that we have created. So you can see, if you just double click on the JSON file, see the JSON file is automatically created. As I said, the JSON file starts with a curly brackets and ends with a curly brackets, and these are the indexes that and the column names that we gave, and every value is actually between a curly braces. Now let's do the reverse. We will now take this JSON file. We have a JSON file in our working directory, right? So this JSON file we will take, and we will create a data frame again. So we will do the reverse. So what we will do is convert, or let's say read would be the appropriate work. We are going to read the JSON file, and how do you read it is, again pd dot, the function for that is read_JSON. So basically two functions you are running now. One is read_JSON and to_JSON. To_JSON will create a JSON file, and we are going to write the contents of our data frame into this JSON file. Read is, we are going to read the JSON file, and what argument that I'm going to give here is for read underscore is I'm going to tell the name of the file that I'm going to read. So name of the file is frame.json. Execute this. So what has happened is it has given, right? It has read the file. So what this function does is reads the JSON file and it is giving us the data frame output as a data frame, which was part of this. So it has read this file and the output what we have got is similar to what we had given here. It's just a bit now it is in a you can see that index is actually automatically arranged in the alphabetical order. So this you saw that it was very fairly simple example, right? Because you have a data frame which is already in the tabulated format. From that JSON file was created and we also did the reverse. Now let's do a little more complex. What we will do is, now let me create a JSON file. We will or let's suppose I have a JSON file which is not having a tabulated data, right? Suppose I don't have a simple JSON file, then what do you do? Right, so I have already created one such JSON file in my system called as books.json. You create a JSON file something like this, which is not as simple as the what we just had, right? So we have a nested, actually this is a nested JSON file, right? Why do I call it as nested? See, I have writers. Under this again I have two curly brackets. Then I have one more writers. Again I have two curly brackets. So this is a tree like, you have a tree like structure in your JSON file. So in real time it happens this way, right? You don't have a very simple JSON file which is just like this, right? You will have a complex JSON file which trees, lots of nodes under it. So books.json is one such example. So what do we do is, first let me upload this file. So how do you upload? What you do is first create a JSON file in your system. How do you create? Just take a notepad and type it. Take a notepad, type it and save it as .json. After that you go to your Jupyter notebook and just upload it, right? Just upload it and then click on this upload button. Fine. So when you click on the upload button, I already have it, so I'm just saying overwrite. So you can see that books.json is now over here, right? So now what I'm going to do is, I am going to take this books.json, but I cannot work it out in a similar way like how I did before, right? I cannot just simply call read underscore JSON and say yeah book.json. It doesn't work. I'll just show you that. If I say it's books or book, I'll just check the name of the file. Yes, it's books.json. So when I just do this, see, there is kind of the representation is not really clear, right? I don't have the complete structure shown here correctly because it's a nested one, right? It's a nested structure. It doesn't really come properly on the screen. So what you have to do is, in such case, you have to do normalization. We call it as normalization. So the library Pandas actually provides a function which will do this, called as JSON underscore normalize. Right? What this function do is, it converts this dictionary or list into a table. It will convert this whatever nested we have into a table. So how do you do it is, just type here from pandas.io, because it's part of the IO functions of that .json. So under pandas.io.json you have a module called as JSON underscore normalize, which I need to call. So did you get this? Under pandas.io.json I have a module called as JSON underscore normalize, which I need to call. So just shift enter. Okay, so there's no problem here. Now what do I do is, I have to now call the JSON file. So how do you do this? First I have to read. I have the JSON file. Suppose let's do like this. Suppose I don't upload. Okay, suppose I don't upload, then how do I do is this? You can also use this command, open and say books.json comma r. So basically what is this? This is a function. R should be in single quotes. So I am using a function called as open. So this open function will open the file in the read mode, because I have given as read. I just want to read the content. I don't want to alter it. Now what do I do is I want to read this file. So I want to read what's there within this. So you just call the read function, and whatever you read, let's put it into a variable called as text. Now whatever I have within text, right, I have to load that, right? So load the contents. I have all the values. See, if you just see text here, let's try to see all the values of this JSON file are here, but it's all like jumbled. I don't want it to involve. I want the output in a structured way. So what I'll do is I will load first the contents of the JSON file. Which one? The books.json file, and convert it into a string. I want to convert into a string. Now how do you convert it into a string? You have a function called as loads for that. So how do you call that? Text, let me put all this into a and again back into the same variable. Under JSON I have a function called as load s. So what does load s do is it will load the contents of this JSON file, and the S means that I'm going to convert it. This S means that I'm going to convert it into a string. So give it back into that, right? So take this text, right, and load it and convert it into a string and put it back into text. Now let's see what is there in text. See the difference, right? So this was the text of the JSON file before converting it into a string and after converting it to a string. You can now see that it is very similar to what I have, right? Now what I'm going to do is, now I'm going to read this value, but I'm not going to use read underscore JSON. I'm going to call the normalize function, JSON underscore normalize, because I have a nested structure. For that reason I'm doing all this, right? So call the text, let's say it is in JSON underscore normalize, and let's give the first argument as books. So basically what happens now is JSON normalize, as I told, it's going to, because I have a nested structure in my JSON file, it's going to make it more structured. Shift enter. See what has happened here. Because I gave the argument as books, it has, for all the books, it is listing out what are the prices. See, I have these books: XML book, Python fundamentals, NumPy library, right? So these are the titles. So it has just taken this part. If you observe, this is my original JSON file, and this is what I have done with normalize. Under books, it has read only these three things, these three values and these three values, right? So it has created a table with a title, taken all the titles of that and corresponding prices it has given, and it has automatically generated an index. Okay, so JSON underscore normalize is doing this work. Now suppose I want to add a few more things into my file. Like there's so many things are still missing. I don't have the writer information, I don't have the nationality information, I don't have it because I did not specify here. So suppose you want it, what we will do, we'll just copy this and extend this. Just put comma and extend. I'm going to extend with a separate square brackets. The reason is because it does not belong to the same node. Now this is a parent node, and I can say this is the child node. So that's the reason I'm not going to put it within this braces. I'm going to put it as a separate comma, and under this I will give, I want to create a node for writer, I want to create a node for nationality. So let's copy this. Writer is one and one more is nationality. Copy this and put it here. Okay, so what we have done now is I have just extended this. I want to add my parent nodes as well, right? So that is why I've added this, right, and this one, and then let's close the parenthesis. Let's not close it here, right? You have to close it now here. So this JSON normalize has three arguments now. One is the text. Text is basically the JSON file, and this is one of the nodes, and this is basically it is the child node, and this one would be the parent node. Just ensure all the parentheses and quotes are correct. So now you see the difference, right? So two more things have been added, writer and nationality, and you have to specify this differently because this is a parent node to it. And see, there is no mistake in the way it is, the data is interpreted, right? Under Mark Cross you have three books, under Barbara we have 3 books. So that was about JSON normalize, right? Where we are actually we use JSON normalize. Remember, we use it when we have a data frame with a tree structure. Okay, just remember this point. JSON normalize will be used when we have a data frame with a tree structure. So just to quickly revise what we have done in today's session is we just went through what is a JSON file, and we saw the object notation of JavaScript object notation, basically what's the difference between JSON and XML, and we wrote our own code where we are actually creating a data frame. From the data frame, a simple tabulated structure of data frame, we created a JSON file, and we also did the reverse. To create a JSON file, the function is to_JSON. To read, it's read_JSON. Now suppose real time it doesn't happen, right? We don't have such simple JSONs. Our JSON files will have a tree structure. It will not be a simple tabulated format. So that is the reason we created a JSON file. You type this JSON file. When a JSON file is created, you have to put it within curly braces like this, and then since we have a tree structure, we are importing the module JSON_normalize, which is under pandas.io.json. So we opened this file, we read this file into read the contents of this file into a variable called as text, and then since this is we have to convert this into a string format using the load_s function. After that we call the JSON_normalize. We first called it under the child node, and then we also called it with 2 more arguments, that is the parent nodes, sorry, that is writer and nationality. So try these examples in the system. So today's class we have only discussed about read_JSON function and to_JSON function, keeping in mind only about the input-output API functionalities. Next class we will do one more very important and very interesting topic, especially in data science. We will see how we can do web scraping, right? We can get details of the web using JSON. Thank you.